Welcome Pure Maths 1 students to week 14 of our maintenance. It's a bit of a longer week, I suspect, seems to be 3 pages. So we'll get into it and go as quickly as we can. So the first question is a quadratics question. We're trying to find the possible values of k for which this line, y equals k minus 3x, is a tangent to this curve here. So you can see that we've got the first one in terms of y. So I can insert this here into this value here of y. So that will give me x squared plus 2x into k minus 3x minus 20 is equal to 0. And if we expand this, we get x squared plus 2kx minus 6x squared minus 20 equals 0. We could simplify this to minus 5x squared plus 2kx minus 20 is equal to 0. And we know that it's a tangent, which means it touches at one point, so that therefore our discriminant is going to be equal to 0. So let's apply that to this. 2k is our b value, so we square that. Take away 4 times negative 5, which is our a value, take away negative 20. This gives us 4, and that's got to be equal to 0. So we get 4k squared, positive 20, minus 400 equals 0. So 4k squared equals 400. So k squared equals 100. So k is equal to plus or minus 10. For each of these values, this is part B, find the coordinates of the point of contact of the tangent with the curve. Okay, so when k is positive 10, then our equation is going to require a positive 10 in here. Okay, so we can chuck that in. What do we get? We get minus 5x squared plus 20x minus 20 equals 0. And then we need to find the point of contact. So what is the point of contact there? Well, we can use the quadratic formula at this point, can't we? So x equals minus 20 plus or minus the square root of b squared, which is 20 squared, minus 4 times negative 5 times negative 20, and that will be all over, what is that, 2 times negative 5. Now, when we chuck this into our calculator, what are we getting? I'm just going to use my equation mode on my calculator, which you might feel is a wise move at this point, just to save yourself a bit of time. There's only one value because that's right, because we've got a tangent. So in this case, x equals 2, and y equals, we can chuck that into here. 10 take away 3 times 2, which is 4. And then when k equals negative 10, the equation will of course then be 5x squared minus 20x minus 20 equals 0. So all that you would need to do there is just adjust your quadratic formula, and then when you do that, you're going to get x is equal to minus 2 and y is equal to minus 4. So the only change that you'd need to do is just adjust. This is going to be a minus minus, right? That will remain the same because once you square a negative, it'll be positive. Anyway, so that's that one. So those are the two coordinates there. The next one, we have a couple of functions, fx and gx, and we've got to find the values for which the equation fg equals x has 2 equal roots. So what we're going to do is we're going to say f, and then we're going to put g into f, so like this, equals to x. Now, this value here has to become our x value in our f function. So the next line is going to be 4 into 9 over 2 minus x equals x. And then we can say, well, that's like 36 over 2 minus x equals x. And now we're going to bring the 2 minus x across the other side to get 2x minus x squared. Bring everything across to the left side to get x squared minus 2x plus 36 is equal to 0. Now it looks like oh, is that a k there? Oh, you know what I've done? I've missed off my k. So here's my problem. When I put that in here, I needed to have a minus 2k equals x. So you can see I've gone a bit wrong there. Let's just fix that up. Check what you're doing as you go along. Okay, so we get 36 over 2 minus x equals x plus 2k. Now I'm going to do what I said I was going to do before, but this time I've got 2 minus x into x plus 2k. I'm going to expand that bracket to get 2x plus 4k minus x squared minus 2kx. I'm going to bring everything across to the left hand side, x squared, and then I've got minus 2x plus 2kx plus 36 minus 4k equals 0. Let's gather all of our like terms. So we've got x squared, and then plus x into minus 2 plus 2k, and then plus 36 minus 4k. So we've got our a value here, we've got our b value here, and we've got our c value here. Now we've got to find the value of k for which it has this equation that we've done has two equal roots. So b squared minus 4ac is got to equal 0. So let's take our b squared, that's minus 2 plus 2k. We're going to square that, minus 4 times 1, and then that just times that last bracket, 36 minus 4k. Now, what is going to happen here? Okay. Well, we'll get 4 minus 8k plus 4k squared, 36, 72, is that 144? Minus 144 plus 16k. Okay, and then we just gather it all together. So we got 4k squared plus 8k minus 140. Oh, let's just make that a bit neater. Minus 140 is equal to 0. Now I think, what can we do there? Guess we can divide by 4. Yep, we can. So k squared plus 2k minus 35 equals 0. And so factors of 35 that add to... Okay, so k plus 7, k minus 5, and therefore k equals negative 7 or 5. So we're good on that one. Now determine the roots of the equation for the values of k that we've just found. Okay, so let's try that. Let's say, so we're going to take this equation here, or even actually, maybe we'll just take, let's see, this equation. Look, we can just use this whole thing here, can't we, really? So we're going to go x squared plus x into now minus 2 plus, now we're going to start off with this one here, the minus 7, plus 2 times negative 7, minus 14, plus 36 minus 4 times minus 7 plus 28 equals 0. So we get x squared minus 16x, and then 36 plus 28 gives us 64 plus 64, and you can see that this is x equals negative 8. You can see that this is just a one of those. Right, and then over here when we try the 5, so we get x squared plus x into minus 2, take away positive 10, so negative 12. Hang on, is that right? Minus 2 plus, oh sorry, plus 10, minus, so it should be positive 8, plus 36 minus 20. So all up we get x squared plus 8x plus 36, take away 20, 16. And so that's x plus 4 all squared equals 0. So these are all equal to 0. Therefore, x equals negative 4. Okay, I think that's okay. Now let's move on to page 2. Now we've got the two vertices of a rectangle, A and B are blah, and we've got to find the gradient of CD. Okay, so if this is A, B, and this will be C, then D. If you can find the gradient of AB, the gradient of CD will be perpendicular to it. Okay, so that's kind of the idea. So let's find the gradient of AB. Gradient AB equals change in y over change in x, so minus 4 minus minus 8 over minus 6 minus 4 is equal to 4 over 10, negative 10 or negative 4 tenths. Okay, so remember we had A, B, C, and D, and we want to know the gradient of CD. Okay, so therefore the gradient of CD is the negative reciprocal, so 10 over 4. I guess we could actually just rewrite this as negative 2/5. And then we could change this one here to 5 over 2. Okay, and we also need to find the gradient of BC. Sorry, we've found the gradient of, yeah, C. Oh, sorry. I should have written, this one here is actually BD, or BC. And then the gradient of BC, CD, sorry, this one here, I'm getting all confused, CD, is going to be the same as the gradient of AB. Okay, and so to our circular measure question, we're trying to find the shaded area here. We know that we've got a triangle, and then within the triangle there is a circle centre O with radius 8 centimetre, and the sector angle is the pi thirds radians, and we've got to find the exact area of the shaded region. So the area of the shaded region is equal to area of the whole triangle minus the area of the sector. Okay, so the area of the triangle, we probably want to find RQ. So let's find RQ. So tan pi over 3 is equal to RQ over 8. So 8 tan pi over 3 equals RQ. Alright. So we can simplify that down because pi over 3, tan pi over 3 is square root 3. So RQ is going to be 8 square root 3. So the area of the triangle is half base, which is RQ, times the height, and then we subtract the area of the sector, which is half r squared theta. Now r is 8, and theta is pi over 3. So what do we get? Well, for 32 square root 3 minus 32 pi over 3. So we can factorize that 32 out of there. So we get square root 3 minus pi over 3, I think, in the brackets, and that would be our answer to that one. So it's nice, a relatively easy one. Now we're trying to prove this identity. My first step would be to cross multiply. So I'm going to get sine x into 1 plus sine x minus sine x into 1 minus sine x all over 1 minus sine x into 1 plus sine x. Now we can, on the bottom, we'll get 1 minus sine squared x, and on the top we'll get sine x plus sine squared x minus, oh, that should be a 1 there, shouldn't it? Whoops. Minus sine x minus sine squared x. Is that right? Oh, well, sorry, positive sine x, right? Because it's this, and I should have a negative here. I see what I did. This is why you write neatly, isn't it, guys? 1 minus sine x. Okay, so that'll give us positive sine squared x. Now, if we look at the bottom, we can rewrite that as cosine squared x, right? Now, this and this are going to cancel out, and then we'll be left with 2 sine squared x on top, which of course is equal to 2 tan squared x, because we've got sine squared x over cosine squared x. Now, next one, we have a graph, and we've got to find the values of a, b, and c, given we've got a sine bx and plus c. So first of all, I think we can say that c is equal to 3, because we've lifted the whole thing up from 0 to 3. And we can also look at a. Now a is the vertical stretch, isn't it? So you see we go from 9 all the way down to minus 3, which is 12, isn't it? It's equal to 12. So we can say, therefore, a is equal to 6. And now, right, because remember with the sine graph, if you just got sine x, it goes like this from positive 1 to negative 1, right? And if you do 2 sine x, then it stretches that to 2 to minus 2, right? So if you've got a distance between the top and bottom of 12, then half that to get your a value. And now this, the next bit here, this bx, you can see that you've got a period of pi, whereas normally it's 2 pi, isn't it? So this bit here that I've just sketched over, that would normally finish at 2 pi. So, so that shows you that you've got twice as many b's happening in the range, so it's going to be b is equal to 2. Now we've got to find the smallest value of x in the interval of 0 is less than x is less than 2 pi, for which y equals 0. Now where does y equal 0? Well, here, right? So we want to solve that. So we can now write our equation, which is 6 sine 2x plus 3 equals 0. And then we rewrite this, 6 sine 2x equals negative 3. Sine 2x equals negative 1/2. 2x equals the inverse sine of negative 1/2. Now, what does this give us? Inverse sine. Make sure you are set to radians. Inverse sine of negative 1/2. And we're going to get pi over 6, negative pi over 6. Alright, so at this point what we're going to do is we're going to draw our sine graph. Okay, and we've got 2x equals negative pi over 6. Well, you could see that that would be somewhere over here. Now in our normal pi graph here, we've got pi over 2. We got 2 pi over here. This bit, this bit here is 3 pi over 2, and this would be pi here. Now if we look carefully, we can add 2 pi to this, which gives us this one here. So that's 2 pi minus pi over 6. And you can see that this is pi over 6 away from 2 pi. So the one that we actually want is this one here, the smallest value. See, the smallest value. So we're going to say this one here ought to be pi plus pi over 6. So therefore 2x is equal to pi plus pi over 6, or 7 pi over 6. And so therefore x is equal to 7 pi over 12. Now the last question for us is we have a curve and it has no stationary points. So what we've got to do here is we're going to differentiate this and show that the gradient is never equal to 0 because it's got no stationary points. So when we differentiate it, we take this number here, 3, we multiply it by the 2 to get 6, and then we drop the power down by 1. Then with this one here, we times the a by the 2, so we get 2a, and we drop the power of the x down by 1. And then this one here, bx, just becomes b, and the 30 drops out. Now, we have to show that in this case, no stationary points, which means that for the equation 6x squared plus 2ax plus b, that then there will be no roots for that. So no roots. Excuse the bad handwriting here. And so we're going to go b squared minus 4ac has to be less than 0. So we chuck in our b value, which is 2a. We're going to square that. Then we're going to minus 4 times 6 times b. And we get 4a squared minus 24b is less than 0. Sorry, I should have had a less than 0 there. Then I'm going to go 4a squared is less than 24b because I'm adding 24b to both sides. I divide by 4 and I get 6b. Alright, I think that's it for today. Hope that's been helpful to you, team. Take care. God bless.